So I am the cloud.
What's with the giant pumpkin?
So 2 guesses as to who made that. This is CS50, the start of week 10, and that is indeed just one of the seminars on the horizon. For those of you after final projects who would like to continue on with your final projects or some other idea altogether, know that this Hack Harvard group started last year is available to you. If you go to hackharvard.org/app, you will be presented with an opportunity potentially to come back a bit early over J-term and work with friends or fellow-minded students on your own entrepreneurship activity. We, quote unquote, are a hub of tech entrepreneurs on campus with a mini incubator during optional winter activities week, January 13th to 22. We offer everything the aspiring entrepreneur or passionate hacker needs to build cool projects. So if you would like to join and apply for that group, head to that URL there. So this week is ultimately about CS50 Shuttle. And I dare say one of the most exciting aspects of this week is that it is your last CS50 problem set ever. We like to think it's also fun. You will recall perhaps from week 0 that in problem set 8, you have the ability to start driving around campus, picking up teaching fellows, CAs, and a few Easter eggs along the way. Where did he go? Well, and when you come up close to one of the staff members, can you click this pickup button at top left or drop them off at their appropriate house? And there's also opportunities to build in some Easter eggs of your own. For instance, those of you who grew up playing Nintendo might recall the Konami code, up, up, down, down, left, right, BA. If you actually type that into the staff solution, you will also acquire the ability to fly. So there you have it, CS50 Shuttle, a framework for which we provide you with, and you then begin to fill in some blanks. So without further ado, today is about introducing the concepts and the techniques with which you can start implementing this as well as your own final projects, and thus enters into the picture JavaScript. So JavaScript is a programming language like C, like PHP, but unlike those languages, it is executed entirely client-side, generally within a browser, although these days server-side options do exist. And like PHP, it is not compiled. So there's no process of running GCC or similar with JavaScript. Rather, you write JavaScript code, you store it inside of your HTML files or PHP files or in separate .js files. And then when the browser downloads that JavaScript code, it executes it. So the CS50 Shuttle implementation is an amalgam of a plugin, which you did have to download separately or will from Google Earth, but also the Google Maps API, application programming interface, as well as just some HTML and JavaScript and CSS that we wrote. And we've wired, so to speak, all of these various tools together so that you can focus ultimately on the logic and on the usage of these tools to make something much more interesting than just Google Earth or just Google Maps standing unto itself. So a few background details. You'll recall we've talked about some of these status codes, 401, 403, 404, 500. Generally, these are bad things. If you are seeing this when working on some project of yours, you've messed up somewhere. Or if you're on the web and you come across a 404, it means someone else has messed up. And just to be clear as to where these messages are being communicated, notice that we can simulate this as follows. And we'll see how far we get by being on autopilot there, another feature of the staff's implementation. Let me go over to my terminal window inside of the appliance. I'm just inside of public HTML. And let me go ahead and run, I'm just going to create a file. And you can create files with the command touch foo.html. And if I now do ls-l, notice that I have already screwed up. Even though my other files in this directory are chmoded correctly, foo.html is only readable by me. And that's a problem if I want it actually to be accessible via a browser. So sure enough, if I go over to a browser, I reload, I can see it in my directory, because at this point in the story, my public HTML, I've actually given readability and executability, permissions to with chmod. But if I click foo.html, you see the familiar forbidden message. And if you really look close in the title bar, you'll see that 403 forbidden does indeed somehow relate to chmod. But because we're now looking underneath the hood, let me also click on Firebug. So recall that that's the free plugin at top right. Let me go ahead and click here and reload, but with Firebug's net tab selected. So in the past, we've played with HTML. You might have played with others. But know that these other several tabs, including console and net and more, are all quite helpful. And you can see in red here that we tried to get foo.html, but it just didn't work. In fact, if I click on that, I can see a sort of user-friendly, nice bold-faced and grayscale version of the headers. But if I click View Source over here, this shows me the actual HTTP headers that were sent. And whereas 200 we said was good, 403 or really almost anything other than 200 is bad. And this is how websites are communicating that information. OK, Safari is getting lonely. So let's go back to Safari. And time is up. So that's a feature 2 of the staff's implementation. So this is just to point out that underneath all your typical web usage, there's some additional, somewhat arcane information that we programmatically are now going to have more control over with this language called JavaScript. All right, so without further ado, here is where you can learn about JavaScript. This is actually a really nice tutorial, but this, much like PHP, is really going to be a bootstrapping process where today and in yesterday's walkthrough and this week's sections, we'll be introduce you to the fundamentals, some of the concepts and the like. But ultimately, it will be up to you with the pset and with your final project to explore further. And this is one particular language guide that points out that JavaScript is actually pretty familiar. So just as with C and with PHP, we have functions. But as with PHP, you don't strictly need a main function anymore. If you want to start writing code, all you'll need, we'll see, is an HTML tag called script. So main won't be necessary, but functions will still be at our disposal. We'll see that conditions, syntactically, look again exactly like this. This was pseudocode from week 1. We stole it 2 weeks ago for PHP. It's exactly the same in JavaScript for conditions, for Boolean expressions, for switches, for loops, for while loops, for do-while loops, and yet more. So we only start to see some differences with JavaScript as follows. So variables have a slightly different syntax. You do not specify their type, just like in PHP. But unlike PHP, there's no $sign anymore. So it's actually a little more succinct. But you do need to say in JavaScript, generally, var for variable. And so this one line of code means give me a variable s and assign it a value of quote unquote hello world. Because it is quoted in this way, this will be an implicit data type of string. So JavaScript does have data types of sorts, but you don't need to explicitly mention them. So here we have a variable s, as we've had many times before. Now arrays, and this is where JavaScript gets interesting and frankly powerful and convenient, because syntactically it makes a lot of things easier. If we want an array called numbers, I just say var numbers. I don't specify in advance that it's an array, but rather I determine as much by assigning it an actual array. And in JavaScript, if you want an array, in this case of integers, all you need to do is do open square bracket, close square bracket, and then a comma-separated list of the numbers that you actually want to store in this array. You don't have to preordain its size. You don't have to call malloc. You don't even have to call PHP's array function. If you want an array, you can simply use the square bracket notation, and voila, you're on your way. Moreover, arrays in JavaScript are what we generally call vectors. They are not arrays in the C sense. They're more arrays in the PHP sense in that they can be resized. You can add more things to them. You can subtract things from them. And there's none of this headache of malloc and realloc and the like. The size, the length of an array will grow dynamically. And then we have some new constructs too. So recall that in PHP, we introduced a for each construct, which you might have found or may find useful. In JavaScript, there's something similar. It's the for element in array syntax. So if you've got an array called array, and you want to have a temporary variable called element or foo or bar or whatever, you simply say for, and then in parentheses, local variable in array's name. And that will, on every iteration, just as in PHP's for each construct, update on each iteration the value of element to be the next thing in that array. And so that's just a handy and popular construct. But perhaps by far the most powerful or most frequently used feature of JavaScript these days is its notation for objects. So indeed, this technology we'll start talking about today called Ajax has really been popularized through the use of something called JavaScript object notation, otherwise known as JSON. And this is simply a syntax whereby you can declare an object with the simplest of characters. If you want an object, think back to C, like a struct, and you want that structure to have 3 fields, let's call it ID and house and name, all you have to do is open this object with a curly brace, close it with a curly brace and semicolon, and then inside of it you can have as many key value pairs as you want, all separated by commas, where the key is to the left of the colon and the value is to the right of the colon. So again, think back to our declaration of student with a type def and a struct way back in C. Well, this is the exact same idea, but if you want it to be declared, it's as simple as just saying, give me an object, call it student, and inside of it here are going to be these 3 key value pairs. Now, to be clear, what is an object? Well, an object in JavaScript will eventually take on even more meaning than we'll look at today, in that it can have functions inside of it and the like. JavaScript is an object-oriented programming language, even though it doesn't have something called classes, with which some of you might be familiar. But this here allows us to encapsulate inside of some big variable multiple data fields. And so in this way are we going to be able to format data and exchange data, especially over the internet, particularly easily. For instance, this is just one student object. It's not all that interesting in a vacuum. But if you actually wanted to have an array of students, students, we might say var students equals, and then open square bracket, because recall that denotes here comes an array. At the bottom, we have another closed square bracket, so that's the end of the array. And then inside of it, we, again, as promised, have a comma-separated list of something. But in this case, the something is an actual object. So the curly brace means here comes an object. Here's a key value, key value, key value. And then the same thing here for Tommy. And so now we have this very clean syntax, arguably, for kind of bundling up lots of information, still semantically tagging it, so that I'm not just sending the number 123 Matherhouse David Malin, but rather I'm associating some metadata with it, these keys that just tell me, the receiver, what these pieces of data actually are. And notice, too, I don't have to mention any notion of data type here. These are very, very generic objects. Notice there is no mention of student with a capital S, no mention of an actual struct name or type def or object. Rather, these are really generic objects. So for better or for worse, JavaScript's notation allows us to very easily bundle up together lots of pieces of data like this. But once we now have these basics, it's more fun and it's more compelling to actually now start using these basic new syntactic features and this client-side language like JavaScript. So without further ado, let me go ahead and open up, let's say, this past example here. This was a very, very simple snippet of HTML from a while back. And it was nice just because it has some basic building blocks. A HTML tag, head, a title, a body, and then 2 tags inside of it, one of which had an attribute. And recall that we drew this thing like a picture, with a picture like this. And what did we call this tree-like structure? Anyone recall? Yeah, DOM. OK, I heard someone with Steph whispering it over here. So DOM, document object model. And that's just a fancy way of saying that if you were a computer or a browser reading this HTML from a text file into RAM, how might you represent it? Well, you could just represent it as a huge string. But if you actually want to do interesting things with this web page and manipulate parts of it, add content, subtract content, well, you would instead want to be able to traverse it hierarchically like this picture here suggests. So this is what really happens when you download a web page with a browser and it contains HTML like this. One of the first things the browser does is it parses it. It analyzes that HTML code top to bottom, left to right. And every time it sees a tag, it creates what we'll call a node, one of these rectangles on the screen here. And every time it encounters another open tag inside of an already open tag, it assumes that that new node or that new rectangle is a child or some kind of descendant of the previously open tag. So in short, with the right logic and with the right code, can you read this file top to bottom, left to right, and just call the equivalent of malloc, 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 and wire these things together, much like you did in pset 6, a hash table or a tree or a trie or any of these data structures that were somehow interesting in memory. So what's neat about JavaScript is that you have the ability now programmatically to change what was sent to the user. So even though you might send them that HTML, you can keep sending them more HTML. Or you can keep sending them, we'll see, JSON data, and then add more and more content to the screen, or even remove it, right? Case in point, Facebook, right? Now with the news feed on the front page, you can constantly see new status updates, and you don't even have to click anything. It will just tell you when some new status updates are available, or you see a little pop-up in one of the corners of the screen. Well, how is that? Well, obviously, Facebook can't foretell the future. When you download the homepage for the first time at like 12 o'clock, well, they don't know what new status updates are going to come, and they don't want you, sort of 1990s style, to have to reload the whole page. And so they push additional updates to you in some manner. So they send you more HTML or more JSON type data so that their own JavaScript that came with the original web page can read it from the internet and then insert it more into the web page. And I would be remiss if I didn't mention that Mark Zuckerberg is indeed at MIT right now, not in CS50, but we will be joined today by Jocelyn Goldfein toward the end of class, who is Facebook's director of engineering. And so these references to Facebook might offer some interesting opportunities for questions about how the real Facebook actually works, rather than my own made-up stories about how it might work. So more from Jocelyn in a bit. But for now, let's actually transition here and start using JavaScript in some way. But let me point out one thing. So think way back to week 0. We had the notion of events in Scratch. And you could broadcast an event, and then you could wait for an event. And we had that very simple Marco Polo example way back when in week 0, where when you hit the space bar, Marco would say his name and broadcast an event. And the girl that was also a separate sprite would wait for that event. Upon receiving that event, she would then say Polo. So events were this way of having two different programs, or two different sprites in that case, communicate. Well, similarly as web programming, asynchronous like that. You have lots of going on modern web pages, and you don't necessarily want to wait for the user's input for something to happen or something to change. You, the website, might want to push more data to the server and say, here's a status update, or Gmail, here's a new email that you have. And so you have in HTML associated with all of these elements we've been using thus far, anchor tags and divs and paragraphs and inputs and select menus. You actually have a whole suite of events that can be triggered. And this is a non-exhaustive list, but some of the most common ones, and most of them kind of are self-explanatory. For instance, on mouse over is an event that is triggered on any HTML tag when you so much as hover your mouse cursor over that element. Now, typically, if you just wave your mouse over a div or over a paragraph of text on a web page that you made for, say, pset 7, nothing happens. But with JavaScript, can you tell the browser, I would like to listen for this mouse over event? And you might recall on many websites, anytime you hover over some text or graphic, what sometimes happens before you actually click? Right, something changes, right? It might become highlighted. It might change to another graphic. It might become bold. Something might change. And that's because of JavaScript, typically. CSS, you can work some of these tricks these days, too. But with JavaScript, you can do anything, because you can detect the fact that the mouse is now over some element in the page, some div or some paragraph, some button, and you can do something. And you can even then detect when the mouse is out of the range of that tag. So you can have things become big and then small, or black and then white, or any kinds of changes you might want to happen. You can listen to keystrokes, on key down, on key up, on key press. These are actually used by CS50 shuttle so that when you do hit the arrow keys, or W or A or the like, we, the JavaScript code in that implementation, are listening for those events. And when we hear you pushing the up arrow, just like in Scratch, we do something. We move the camera, or we move the shuttle in that case. And there's yet others on submit, on select, on resize, on click, and so forth. This means that we can listen for all of this. So let me go into the appliance here and open up gedit with a file called form1.html. And this is going to be a very simple form that submits only to a file called dump.php, which does nothing interesting. I just wanted a page to which I could submit all these forms that would just show me what fields had been submitted. So it's not really a dynamic website. It's just some diagnostic output. So let me go ahead and look at what this thing looks like. If I go into form1.html, we will see a little form like this. So pretty typical, an email field, password, again password, and then I need to somehow agree to these terms and conditions. Unfortunately, if I submit this form right now, nothing actually happens in a good way because it does submit the form. It submits no values for those 3 fields. It doesn't even send the checkbox field because it wasn't checked. And so what could I do? Well, just like with the Frosh IM's examples last week, I could yell at the user, right? This PHP file could notice this field equals the empty string. This field also equals the empty string, quote unquote. So let's yell at the user in red. But JavaScript is nicer in that we can detect this even before you click submit. And this is increasingly compelling because you don't want to have to submit, maybe wait a second or two while your slow laptop or slow internet connection actually sends the form to the server, only then to be told, sorry, you screwed up, try again. It'd be much nicer if we could instantaneously tell the user, wait a minute, you forgot to do something important. So we can add a bit of client-side validation. In version 2 of form, let me go ahead and try that same thing where I just submit a blank form. And now notice the website's yelling at me. It's sort of using a very coarse trick, using an alert menu, as it's called. But it's at least now preventing me from submitting the form, and it's explaining why. So I click OK. And now notice I did not, in fact, end up at dump.php. I'm still at the original URL. So it seems like with JavaScript, you can listen for an event like onSubmit. And if you decide, wait a minute, I don't want to submit because you have not you have not inputted everything I want, you can short circuit that connection. And frankly, increasingly these days, you have Android phones, Windows phones, iPhones, and the like. These are not the fastest internet connections, especially when you're on 3G or similar. So the avoidance of this round trip time that could be 2, 3, maybe even 5 or more seconds is increasingly compelling to try to do it all on the client side to speed up the user's experience. So let's see how this is actually working. In form2.html, we'll see the same HTML as was in the other form. So let's just look at this version because it's identical to before, almost identical to before. And now notice we have a body tag. We have a form tag whose action is, as promised, dump.php. We're just using get because it doesn't really matter for this. But notice I've given this form a name. So that's a little new. So name equals quote unquote registration because this is a registration form. But notice this too, another HTML attribute. OnSubmit equals quote unquote return validate. So we seem now to be calling code inside of an attribute's value in HTML. And we'll see that there's actually cleaner ways to do this, and we'll get there. But for now, this seems to be saying call a function called validate with no arguments, and then return its value. And what HTML is designed to do is if this function, validate, returns false, what's going to happen? The form will not, in fact, get submitted. Only if that function returns true will the form proceed to go to the server. Now, the rest of this is old hat now. So we've got an email field, which is type text, password field, which is type password, another one for password, and then an input type equals checkbox. So everything else is the same, but I do have a submit button. So indeed, when the user hits enter or clicks that button, that function, validate, is going to get called. Well, if we scroll up, notice that we've introduced a new feature into the head of this web page. Inside of the head usually is not only the title tag, but now we also have a script tag. And the default language these days is assumed to be JavaScript, even though back in the day others were sometimes used. But for now, this is pretty much the de facto standard. And inside of this script tag, we actually have programming code. Not C, not PHP, not HTML. This is now JavaScript. And this is more verbose than we're going to need to be ultimately. But let's see what this function does. So just as in PHP, you must literally say function and then the name of the function. And it takes no arguments in this case. Then we have the promised syntax of if conditions, which look pretty much the same. But this is a little new. So it turns out that per this picture here, whereby you have a so-called document node at the very top, sort of the grandparent of this whole tree structure. Similarly, in JavaScript, you have access to a special global variable called document. And it's specifically an object, which means inside of document are a whole bunch of key value pairs. Now, for now, you can just simplify this. Inside of the document object is another object called forms. And this forms object is just an object containing any of the HTML forms that are in this web page. There might be 0, there might be 1. In this case, there's 1. And if you then go .registration, this means give me the form whose name is registration in this particular web page. And then you can kind of continue the logic fairly intuitively. .email means get me the email field in that form called registration in this web page. And then lastly, because the email field is really referring to an input element, we really care about its value. So value equals quote unquote something. So we say .value. And finally, after traversing this very long hierarchy of objects, but arguably intuitive hierarchy, we're checking, does that value equal the empty string? Because if so, we want to yell at the user. So a very simple way of yelling at the user, even though it's not the prettiest way, because different browsers create different aesthetic windows, alert literally just alerts the user with a modal window, which means you can't do anything until you click OK in this window. And I'm returning false, moreover, to make sure that not only am I yelling at the user, I'm short-circuiting the form's submission. Now, the rest of these are somewhat intuitive based on that explanation. So even though the syntax is, again, a little verbose, document.forms.registration.password1, this was the first of my password fields, .value equals quote unquote nothing. I'm going to yell at them for not providing a password. But just like in most websites, if the user screwed up their password second time and I did not type the same value for password 1 as I did for password 2, I'm going to yell at them again, but slightly differently. You must provide the same password twice. So again, this is just basic logic now that we might have used in C a few weeks back. But notice the difference. Just like in PHP, if we want to compare strings, we do not need to jump through the hoops of something like strcomp. We recall we had to avoid this issue of pointers in C and comparing pointers instead of strings very nicely in PHP and in JavaScript. And in a lot of these so-called higher level languages, when you say equals equals and you're comparing strings, that's going to do a literal string comparison in the manner that you would have expected. And then lastly, notice this. It's slightly different from a text field, but I'm saying else if it's not the case that document.forms.registration.agreement, agreement is the name I gave to the checkbox, .checked. So if it's not checked, that's a checkbox, so it actually has a Boolean property called checked, which is either true or false. So if it's not checked, I'm going to yell at them for not agreeing to our terms and conditions, return false. Otherwise, if they passed all of those tests in that gauntlet, I'm going to go ahead and say return true. And what happens then? The user submits the form OK. Yeah? Do you have to specify the return type of a JavaScript function? No. So just as in PHP, it's very loosely typed, so you do not specify the return type. You literally say function and then the name of the function. You can. So PHP and JavaScript are messy in that, as you point out, you could return true or false or 3 or 5 or quote unquote hello. You can indeed return different data types in these languages. Sometimes that's advantageous. PHP takes great use of this, but it's also potentially a bad thing, especially when if you want to return a number like 0, but you might also want to return false, you get into interesting predicaments if you don't distinguish those two cases properly. But for the most part, it tends to expedite development and generally be a helpful thing, even if inelegant. Yeah?
So given that you're returning false if any of those conditions are true, what work does writing else if do rather than just writing false?
Good question. None whatsoever. So I was just being kind of anal, trying to keep it clear to me that only one of these is really going to matter. But because we are returning false immediately, we could get rid of all of those else ifs. Either way would be fine. Yeah? Good question. Thankfully, no. So question is, when you return false, does the browser clear the form? No. It leaves it exactly as is. So this is in contrast with some behaviors of websites whereby once you submit, they get to the next page, you're yelled at, then you click back. Sometimes then, if the page has not been designed to be cached, you would lose all of your inputs. This leaves everything the way it was. Just doesn't allow the form submission. So you might be thinking now, all right, this is great, right? I don't have to jump through these hoops like we did last week with all the Frosh IMs examples. In CS50 Finance, I didn't have to do all this error checking server side and make sure that the user didn't type in negative numbers or bogus symbols or the like. So why not just do all of your checking client side? Well, unfortunately, anyone with an internet connection in Google can go up to, for instance, a web page like this. And let's say, where is it? Tools and not tools, edit. Preferences. Oh, let's do this actually. Disable JavaScript, all JavaScript. So now, let's see what becomes of my error checking. So this is my form 2, which before did yell at me when I didn't submit anything. I'm going to go ahead and, again, not submit anything. And unfortunately, disabling JavaScript does exactly that. It disables JavaScript altogether. So then what is the point, right? If you can do this error checking client side, and yet it's so easy for anyone with a freely available plugin to disable your error checking, what's the value, arguably, still of these techniques? It kind of feels like a waste of time now, yeah? It is. It's still faster. And increasingly, right, we're in this Web 2.0 or Web 3.0 era, right, where like expectations have risen of web pages. And one of the reasons that Gmail is so popular and well used even in a mobile context in the web browser is because they've created the illusion of rapid responsiveness. Even if you're on a super slow 2G or 3G connection, your Gmail interface, if you pull it up in gmail.com in a browser on a phone, it's actually still pretty zippy. You can compose a message and hit send and go back and forward, but that's all JavaScript. Because what Google's doing in that case, if you've used the mobile client, the mobile website for Gmail, is they're hiding all of the latency, all of the slowness for you by doing it effectively in the background. So with JavaScript, we can at least improve the user's experience, even though this really now just means more work for us. Yeah? Good question. Is there a way to detect if a user has disabled JavaScript? Yes. So you could, for instance, have a piece of code in your page that is supposed to like plant a cookie on their browser. And then if the next time the user visits a next page after clicking, you see there's no cookie, it must be logically that your code never executed, ergo it's been disabled. So you can do tricks like that. But really the lesson here is that JavaScript is not an alternative to server-side error checking and server-side validation. And one of the most common ways for websites to be compromised these days is because developers think that, oh, well, I've got my JavaScript checks here. The user can't submit a field that's more than 100 characters long. So I don't need a MySQL column that's more than 100 chars long. And yet they don't check for the same thing server-side, and bad, unanticipated things can happen. Yeah? So that is up to you. So if you're doing client-side checks, will the server-side checks still execute? That's entirely up to you. So if I melded last week's Frosh IM's examples with this week's registration forms examples, we would have a much more robust solution that's very zippy. I immediately get yelled at if I screw up. But also, if I somehow get through and circumvent these error checks, the PHP code is still going to yell at me. So one of the nice things, too, that we'll talk about later this week and beyond is these various frameworks and libraries that I keep alluding to. And we'll look briefly, perhaps today, at one of the most popular. So increasingly are there tools, frankly, that eliminate this redundancy, whereby you, the programmer, can write something just once server-side, and you can even have JavaScript code automatically generated for you that does the client-side checks as well. So realize when you do it by hand, though, there is this additional layer. So let's try to take things up a notch here. This was version 2. With version 3, let's go ahead and just show a different way of achieving the same task, so as to introduce one other concept. So this is version 3, and the only difference here for the moment is this. Literally, I am now calling a validate function, but passing in an argument that's a special keyword. Some of you with Java backgrounds might remember this. This is a pointer of sorts. It's technically a reference. And in this context, because I'm using the keyword this inside of double quotes, which map into a form element, this is like a pointer to that form element. What does that mean? Well, even though it's at this moment in time just text and it's just HTML, when a structure like this is built up in memory and that line of code executes, this will be literally pointing to whatever the form element is, one of these rectangles. So via the this keyword, you can pass in a pointer or reference to a specific node in the tree. And you can do so via your HTML. So now if I scroll up here, my code has changed ever so slightly. And this way isn't necessarily better, but it just demonstrates how we can now pass nodes from our tree into code that we write. So now notice this time I have function validate, but now it takes a parameter, f. I am not specifying a data type. You don't need to do that. Just a name. And I called it f for form. And now notice I can have slightly shorter notation. If f.email.value equals nothing, yell at the user. Else if, else if. So the takeaway here is that this is now allowing me, one, to shorten my syntax, but that's not all that compelling in this case. But it is allowing me somehow to pass these nodes around as though they're indeed objects in a tree. And that'll become more important as the code gets more sophisticated. Well, now we can do one other thing. Let me go ahead and open up with my browser version 4 of the form. And notice that it has this feature that you might have seen on various websites. But now we can see how to do this. So notice that no matter how hard I try, I'm clicking on my mouse here, I cannot submit this form. Because it turns out that HTML has an attribute for buttons called disabled. And you can disable the clicking of a button, as simple as that. So now it doesn't matter if the user doesn't type in anything or types in something completely bogus. If I try submitting, nothing's actually going to happen. But again here, right, we all know that we have tools like Firebug. If I right click on this and I choose open up Firebug, open up the HTML. Long story short, I can open up all of my HTML here. And then I can actually remove the disabled property. If I scroll down, let's zoom in and scroll down here. So let me just go ahead and remove this. All right, so we did this before when we implemented fake Google. Voila, there goes your error checking. Now, no reasonable human is going to do this. And they're only wasting their own time if they're going to do this. But it does, again, send the message that you still have to be having these checks server side. So what did we do in the code to actually do this? Well, actually, let me go back and show the proper behavior. Let me reload this page before I tweaked it underneath the hood. Go ahead, reload. All right, let's try this again. Form 4. So there it is, disabled by default. But notice when I check this box and, oh, wait, that's why. JavaScript is still disabled. Most of these demos won't work then. All right, let's go back here. Form 4. All right, click this. There we go. So notice we now have programmatic control over the DOM of our page so that I'm probably listening for that event called onClick. When I hear it, I'm grabbing a pointer or a reference to that other node in the tree, the submit button, and toggling programmatically that disabled state. So let's go ahead and see this here. Let me scroll down to this form. Notice I again have the validate function here, but I have another one. I have another event handler here called onClick, where onClick equals quote unquote toggle. And this is otherwise just associated with this text box. Let me scroll back up to the top here and see what's going on. Well, up here, not only do I have a validate function, I also have another second function also inside of my script tag. And it's actually pretty simple. A little verbose, but intuitive nonetheless. Function toggle, when it executes this branch. So if document.forms.registration.button. So what is button? Let me quickly scroll down to the bottom again. And now notice I've been giving these things names as I want to refer to them. So let me scroll down, down, down. There it is. I literally gave this input element for the button a name of button. But I could have called it anything. So now if I scroll back up to toggle, I now have if the button's disabled Boolean property is true, because that's all in one big set of parentheses, then go ahead and set the same thing, document.forms.registration.button.disabled to false, else set it to true. And simply by tweaking these properties inside of these objects on the page, I'm able to change the aesthetics of the page and also the functionality. So again, we have now programmatic control of the DOM based on these event handlers that I'm now listening for. Well, let's look at now version 5. Version 5 is kind of sexy because I'm finally not just checking if the user has typed in something for their email address. I'm now using a feature called regular expressions. And some of you might have stumbled across these already for PSET 7, though it wasn't expected. But for your final project, you might indeed want to be able to not only look at a user's input, but also check, does this match a pattern that I want to see? Right? Back in the day, even Facebook would restrict access to people only with a harvard.edu email address. So this suggests that you want to be able to look at a user's input and not just check if it's quote unquote or something else, but you actually want to analyze its pattern. Well, you can actually do this relatively easily in JavaScript and PHP. And in JavaScript, the syntax is this. So notice this expression now. If it is not the case that document.forms.registration.emails.value, so here's another new lesson. Whereas in C, once you have a variable like a string, that is a data type. You can only look at its chars and the like, but there's no functionality built in. Notice here that email is the name I gave to my input called email. But I apparently am going one step further, and I'm actually calling a function. .match means go inside of this DOM node, inside of that rectangle, and call the function called match. So this is an example of this thing called object-oriented programming. Again, Java has this, C does not. PHP does, but it's not always used by folks. So this just means match the value of whatever the user typed in against this expression. And frankly, this looks more cryptic than it really needs to. But the slash there and the slash there just means here comes a regex, a regular expression. And what is that expression? A regular expression is just pattern. The pattern here is dot, and dot generally denotes anything, some character. Plus denotes, anyone know? At least one. So plus means one or more. So this expression, dot plus, means some character, whatever character, one or more times. And it doesn't have to be the same character. It just has to be a character, a one or more times. @ sign means the @ sign. Then we have dot plus, which is the same thing again. It doesn't have to be identical to the characters, but it means one or more characters here. / dot means probably what? Literally a dot, right? We have a little problem now. If dot means something special, but we want a dot, we need to escape it, as we did in C with new lines and things like that. Edu means edu, and then $ is a special token that just means match all the way to the end. Frankly, I've never come up with a good intuitive explanation of this, but $ means that .edu has to be at the end of the string that you're matching. And the opposite of that, for those who are curious, is a caret symbol, of all things. They're not really opposites. But for now, all I'm asking the question, just like Facebook version 1.0, was did the user register with some address ending in @something.edu? So not even Harvard in this case. Now, of course, this is not perfect, because this would allow the user to do crazy things like my name is Malin @Mather @Harvard right? You could do some crazy things so long as it ultimately ends in .edu. But there are more rigorous regular expressions you can use. And frankly, the strings, the patterns get so long and complex, generally you would then start using a library, someone else's code who has figured out all of the nuances of possible email addresses in order to validate them. But you might find, especially if you're using your college address, has anyone ever gone to a website, tried to register with like username @college.harvard.edu, only to be told that this is an invalid email address? Anyone? This happens to me once in a while. So why is this? It's because some programmer decided that every email address on the internet is of the form something @something.something. They didn't even think about subdomains, which are quite common here at Harvard, Post, at college, at FAS, and the like. So there's nothing more infuriating than well, if you're really uptight like me, than trying to register with a legit email address, and the programmer just hasn't anticipated it. But why? What explains that issue? Most likely, it's a client-side JavaScript check or a server-side JavaScript check that is using a bad regular expression. But at least now we can check if they actually gave us something that looks like a .edu email address. But we can even do better. So in version 6 of this now, I just wanted to introduce a little library, something called jQuery. So jQuery is often conflated for JavaScript. This is a third-party library, so freely available code that other nice people have put together that's incredibly common, so much so that these days almost anyone who uses JavaScript uses jQuery because it simplifies the kinds of things we were just doing, right? Even I was getting bored verbally of saying document.forms.registration. This is very tedious, and it's not fun programming, as you might already know, when you're just typing stupid stuff all the time. So jQuery really tries to simplify the syntax and make it more concise. So how can we use jQuery? Well, notice this form of the script tag. So this is version 6 of our forms today. PDFs and code are online if you want to play along. But in the head this time, notice that I have another script. This time it's not immediately closed. Instead, it has a source attribute. And that source attribute is to this URL, jQuery latest at some URL. Let me go into my browser. And let me open a new tab and paste that in. So this is jQuery. And some of you who might be using it but might not have ever looked, this is just a whole lot of JavaScript code that, again, some really nice, smart people wrote, made freely available, so that all of us can benefit. It's a lot of code they wrote. From the really a lot of code they wrote. I've never actually done this. There's a big library. Oh, my God. All right, so not the point, though. The point, though, is that there's a lot of functionality built into jQuery, and you can start to do really fancy, really sexy things without having to reinvent the wheel yourself, right? You know from Facebook and from Gmail and all these popular websites that there's very popular paradigms now, little buttons that kind of glow or have grayscale effects, drop-down menus that don't look like the 1990s drop-down menus anymore, little autocomplete widgets that show you who your friends might be when you're typing in the search box. All of these features that are entirely written in JavaScript, but if they're this common, it's really nice to be able to stand on the shoulders of other people, use their widgets or their libraries, much like jQuery here. So just a quick example of how jQuery works here. Let me zoom in on my HTML. And we'll see that things like jQuery and more generally JavaScript let us write better code. Now I have here in my HTML no mention of JavaScript. Frankly, it's a little messy that we're already commingling sometimes CSS with HTML, which is a different language inside of double quotes and style attributes. Now we had introduced a moment ago all of these function calls like validate and toggle inside of our HTML. And this really kind of violates good design principles, which generally say keep your data separate from your presentation thereof. Keep your aesthetics separate from your logic. In other words, do all of the interesting coding and the computer science-like stuff in one file and relegate things like aesthetics of HTML and CSS to separate files altogether. And that's kind of what we've done here. Inside of this HTML form now is no code, is no logic. But if I scroll up here, let's see how I'm nonetheless validating users' input. So it's very important that I'm loading the jQuery library first before my own script tag, because that library has to load before my own code executes. So it is the case in web pages that URLs are loaded in the order in which they appear. And so in this case here for the script tag, this means jQuery will be available to me. All right, so what am I going to do here? Well, this is going to look a little cryptic since we've already introduced one language today. This is still JavaScript, but it is now using a library. And this is the very common paradigm. So rather than say literally document, we have to pay a slight penalty syntactically. $, open parenthesis, document, close parenthesis is essentially identical to just the keyword document from before. But there's going to be some fancier features that we get as a result. But now I'm saying this, .ready. So ready is a special function that comes with jQuery that says once the whole DOM has loaded into memory, do the following. And this is important. Just as URLs are loaded top to bottom, so are your nodes in this tree loaded top to bottom. So it's actually problematic if you start writing code that tries to check boxes or validate form fields or does anything interesting on a DOM if only the first 2 or 3 nodes have been loaded. So really, you generally want your JavaScript code only to execute once the whole web page is loaded. And that could take a split second, could take a few seconds if there's lots of flash files and video and sounds and the like. But ultimately, we want to wait till that has at least happened. Well, now what this is saying is when the whole DOM is ready, do this. Now, unfortunately, to do this, we need to create a function on the fly. And this will only scratch the surface of this feature today. But what's really nice about JavaScript, and you can do this in PHP, but it's a little nasty, the syntax for it, function, open paren, close paren, gives you a function. But it doesn't give it a name. And in fact, when I do function, open paren, close paren, curly brace, what I'm essentially doing in all of the lines that follow, per the indentation here that implies that they're all part of this function, is I'm declaring what's called a lambda function, Lambda, or an anonymous function. And the latter name is a little more straightforward. It just means a function without a name. Because I don't care what this function's called at this point in the story. I just want a whole chunk of code to execute when the DOM is ready. So by creating this anonymous function, I am handing to the ready function an argument that's only going to be executed when the DOM is ready to do so. If I didn't wrap it in this function, just like in C and PHP, if I just start writing lines of code, they would all be executed right away. And that's bad, potentially. Again, I want my whole DOM loaded into memory. So for now, even if that's a little unclear, just take on faith that this means when the DOM is ready, go ahead and call this code. That doesn't need a name because I'm only going to call it once. I don't need to call it again and again. So now notice this line, $, parentheses, quote unquote, sharp registration. So recall from CSS that you can give unique IDs to various elements in an HTML page. And if I scroll down to my form here, notice that I have a registration form. And I didn't give it a name this time. I gave it an ID. And this, again, is a very common paradigm in JavaScript and in CSS. If you want to be able to hone in directly on a specific node in the tree, you might as well give it an ID, which by nature is supposed to be unique. These are unique identifiers. And I could call it anything I want, but I called it registration because this is a registration form. Now, if I scroll back up in my code, let's see what I'm doing. Rather than have HTML and say an attribute of onSubmit, I'm now doing this programmatically. So this, again, suggests better design. It's more complex at first, but better design. So this means, in jQuery, go get the DOM node whose ID is registration. And the fact that I use the little hash symbol means go to find the ID matching registration. And then .submit is a special jQuery function that simply says, when that element is submitted, call this function. And again, I don't care about the function's name. It can be anonymous. And so I just say, execute all of this code here. Now, I could go back into a previous example and just copy paste the if, else if, else if, else if from before, and it would work. But I can do a little better now. I can shorten that syntax and do it a little more elegantly, even though, again, it's going to be elegant as in the eye of the beholder today, perhaps. I'm going to first check if it is not the case that the email node's value, so this is a jQuery function, get the value of this node. So again, sometimes this feels a little stupid. We previously would have just said .value. Now we're saying val. But so be it for now. You'll trust us that more interesting things will come from this. If it matches this regular expression, well, yell at them. If it does not match that regular expression, yell at them, because they have to provide an edu email address. Similarly, if the value of password 1 is quote unquote, yell at them. Else, if they're not equal, yell at them, and the like. And the takeaway here, even though this is a lot of syntax, is that now all of this code has been decoupled from the actual HTML. So just as the jQuery folks factored out all of their huge source code into a separate file called jQueryLatest.js, so could I do that. I could highlight all this as I've done, click Command X to cut it, paste it into a new file called lecture.js, and then include lecture.js with another script tag with a source attribute like this in order to actually factor out my code entirely. And so indeed, when you go to websites, and we can see this here like facebook.com, and we open up something like Firebug and click this time on its script tag, and you'll have to generally enable these things by default, you'll see all sorts of scripts that have been downloaded in the page. And I'll just glimpse just a couple of here. All throughout modern websites, you'll see either in the page itself or in included pages, script tags, and then link tags for CSS files and the like. And that's because much of the JavaScript that drives Facebook is in these external files that are either downloaded when you first visit the website or over time as you try to click on other features of the site. Well, let's look at just one seventh and final example here. This is code that I did not write. This is from jQuery's own tutorial. It's written in a slightly different version of HTML. This here is called, this is HTML4. So it's a slightly older version, and it's been cleaned up. You used to have to write crazy things like this. Not so in HTML5 anymore. This isn't the best style, frankly. This code is kind of all over the place. But let's see what it actually does. Let me pull up version 7 of this. And we'll see here that this too is using jQuery, but much better, much more compellingly than my own limited web skills. You now see here in this HTML form, one, a visual clue that these fields are required, apparently, based on the stars there. But you'll notice, too, that if I click Submit, notice what immediately happens is nothing. Nothing. David. All right, stand by. What a perfect note to end on. One. J Harvard. Forms. Form 7. OK. Well, now I look like an idiot in front of our special guest today. All right. So what would have happened, and stand by, can I recover from this? That is correct. jQuery latest. I'm just going to have to pretend. OK, so what you would have seen is immediately upon hitting submit, you would see, unlike as is the case on a lot of websites, you would see red text to the right of these form fields yelling at you, not in the form of this sort of annoying little pop-up menu, the thing called an alert window, but rather you would see it inline in the text. And that, too, is using JavaScript to actually manipulate the DOM. Let me see if I can simulate this by going to the actual facebook.com. Let me click sign up here. Aha. So this, too, is now JavaScript. Woo, nice save. So You must fill in all of the fields. So Facebook got this right, even though I did not. So with that said, let's go ahead and take a 2-minute break. And then in just a moment, I'll introduce our guest for today. All right, so we are back. So it is my pleasure to introduce Jocelyn Goldfein of Facebook, the Director of Engineering, who's formerly at VMware, a company that works on virtualization products, not unlike our own VirtualBox. And Jocelyn is here tonight today with Mike Schrepfer and soon Mark Zuckerberg on campus to chat with CS and aspiring computer scientists everywhere later. So Jocelyn, welcome.
Thank you so much. I'm going to tell you that at Facebook we have a tradition of doing it live, so I have mad respect for the live demo, even if it doesn't always go perfectly as intended. So the beauty of building web software is if things don't go exactly how you want, it's very quick to fix it. Maybe some quick mutual introductions first. So I know you guys are all students of CS50, which means right away you're doing something really good with your lives. I don't know if you all remember the internet meme. You are. I don't know if you remember the internet meme from a few years ago, which was commencement advice, which advised new graduates, a whole lot of advice, but above all else, wear sunscreen. So my amendment to this advice would be, above all else, wear sunscreen and learn to program in your life. I think it's a really important part of whether or not you become an engineer or major in computer science or want to build software over the long haul. I think mastering these basic principles is actually applicable to any and every job you might do with your life. So that's the one thing I know about you, and it's already a great thing. Give me a show of hands. How many of you are thinking of majoring in computer science? Okay. Or in any other engineering discipline? Okay. How many of you are sure you're not going to be engineers? Still smart to take this class. How many of you are freshmen? Sophomores? Juniors? Seniors? Grad students? Any? Bueller? All right. Still smart to take this class. Excellent. A little bit about myself. I have had a varied and interesting career. I was a computer science major myself, lo these many years ago. I graduated from a left coast university, Stanford, and I've worked at a variety of interesting companies, but for our purposes, maybe one of the most interesting is that I founded my own startup with a couple of my coworkers and did that for about 18 months. And I stopped doing that after one too many strategic pivots, and also because I was in Austin, Texas, and I really wanted to get back to California. At that point in my career, I'd figured out that I had as much of a Jones for building teams as for building software, and so I went into VMware as an engineering manager, as a manager of teams of engineers. And when I joined VMware, it was about 350 people. And that was really the beginning of a rocket ride for VMware, which doubled headcount every year for the next 5 years. And when I left VMware a little over a year ago, it was about pushing on 10,000 employees. So power of compound interest at work. And when I left VMware, I was pretty determined to get back into the startup environment, and I was really only talking to very small companies. I ended up interviewing with Facebook almost as an afterthought, kind of as a favor to a friend who was working there. And I just kept having these interesting conversations with Facebook employees, and I finally decided that Facebook had more of the qualities that I was looking for in a startup than a lot of the startups I was talking to, and among other things had kind of a trite observation in hindsight, but had far and away the most impressive founder, that being Mark. So I happily accepted employment with Facebook a little over a year ago and have not looked back since. It's been a wild ride. If I was trying to sort of compose some remarks in my head and think about what would I have wanted to know when I was an undergraduate taking an intro programming class, trying to decide whether or not I wanted, what I wanted to do with this and would I continue on. And I think the thing it would have been really valuable to me to hear about is what exactly is the life of a software engineer like? Because, we don't really get exposed to that very much. It's not like, I think we all have some idea of what doctors do. We go to the doctor's office. We have some idea of what teachers do. We encounter them every day. But I didn't really know what software engineers did. And the media representations I got were all about like hacking into the FBI and starting World War III, which, it turns out is not the bread and butter of the working software engineer. So what is it? And, I think that above all, the quality that defines the software engineers that I have most loved working with is that they really love to build stuff, and they really want to make something from nothing. And if I think about the traits that Facebook looks for in the software engineers that we hire, the first trait we look for above all else is passion, a degree of excitement about what you're doing. And I think this maybe applies to kind of all engineering domains, whether you're in, you know, and think about things that you love using and who must have made them, and think about buildings and bridges, but also cars and phones and software. And you kind of know when you're using something that someone just sort of phoned it in. And you kind of know when you're using something that someone worked on that they were just in love with what they were building and wanted to make it awesome. And so I think that quality of being in love with making things and wanting to make awesome things for other people to use, that I think is the quality that at heart unites us all and makes us engineers. Second to that, of course, Facebook wants people who are really good at what they do, who are smart and very capable. And I think that one of the qualities also that makes software engineers really good at what they do is actually just sort of a willingness to roll up their sleeves and dive in and get things done. And you know, Facebook in particular values just doing it live, like trying something, see if it works. If it doesn't, fix it, move on. And really, we have seen over and over again the virtue of trying something quickly, making a difference, and learning from that rather than spending forever kind of planning or thinking about what it should be. So we tend to have really broadly three sort of categories of work that Facebook engineers do, ranging from systems work. So if you think about the kind of systems problem Facebook has, we probably have built sort of the single most well-used application that exists. One of my teams is the newsfeed team, which owns the Facebook homepage. And I think there's a pretty good chance that that piece of software gets more hits per day than any other piece of software in existence, which is a little humbling when we think about submitting code and changing that page. And yet we do that every day. Usually not on weekends, every weekday. And so that's kind of, you know, that kind of systems challenge is, I think, the defining distributed systems problem of our time. So if you think about distributed systems, if you think about cloud scale, if you think about the ways that we divide and conquer large workloads, Facebook is doing some extremely cutting edge work in this area. And I'll give you just one, for example. We actually now custom design our own hardware. We no longer buy off-the-shelf parts because our hardware is so tuned to our workload. But we have put so much energy and inspiration behind the designs of our proprietary SKUs that when we actually go take commercial benchmarks that are like performance workloads and power efficiency workloads, the Facebook designed SKUs actually outperform the commercial SKUs. So the server designers at Facebook are actually designing better servers than people whose job is to design servers for a living and sell them to other companies. So that, I think, is kind of amazing and crazy interesting. We have a class of work that is algorithmic in nature. That, you know, anytime on Facebook, you know, we know for sure that making people think is always, that if you force people to jump through hoops and make people think, they're going to have a worse experience. And so we always want to try to present to users what it is that they want to see by default. And so there's a variety of ways where this comes into play. When you're searching on Facebook and you're searching for a person, we do our best to figure out exactly who you mean and bring that result to be first. When you're reading through stories in your newsfeed, we do our best to try to figure out what are the stories that you are going to be really pissed if you miss and pull them out of order and stick them at the top so you don't miss them. There's a variety of other places where behind the scenes we try to show you the right result first. And so collectively, there are a large number of functions at Facebook that are doing really interesting machine learning work, essentially, to try to divine, you know, what is it that people are trying to do, and let's put it at their fingertips. Last but not least, and closest to my own heart, is what I would consider sort of pure product development. And when Facebook says product, what we mean are features that our end users are using on the site, on Facebook.com or in our mobile applications. And that kind of feature development is really, if you like, I'll say the top of the food chain. I mean, where it all comes together and gets exposed to users. And so maybe I'll talk a little bit more in detail about what you do if you're engineering, if you're building a product at Facebook. So it starts with an idea, and ideas for a new product or a new feature at Facebook come from all kinds of places. We're famous for our hackathons. Every couple months, we'll declare it to be a hack night, and or a hack day, and we'll basically take the next 24 hours, and people will sort of set aside everything else they're working on, and they'll just work on an idea that's interesting to them. And it's very rare, it's next to impossible that you're going to build something in 24 hours that we're going to ship on the site the next day. But what comes from that hack culture is that you have a chance to set aside kind of the nitty-gritty, you're in the trenches, you're very focused on what you're doing, and you have a chance to step back and dream big. And 10 hours of solid coding without interruptions, without interviews, without meetings, is actually an opportunity to really build a prototype, especially if you grab 3 or 4 other people into your project with you, to build enough of something to show people the concept to get them excited about it. So some of our best product ideas have come from those hackathons. Sometimes they come from the outside. They come from users telling us things they would love to see on the site. They come from an individual with a great idea. But I think engineers with an idea always have sort of a built-in advantage over anybody else with an idea, because an engineer has the power to flesh their idea out into a prototype. You know the saying, a picture speaks 1,000 words? Well, a prototype speaks 1,000 pictures. And so that power, seriously. And so, Silicon Valley is full of people running around to VCs saying, I have this great idea. Will you give me some money so I can hire some programmers? The VCs tend to say, no. Because everybody has an idea. Like, tons of people have ideas. The value is not in the idea. The value is in actually expressing the idea and building the idea. So VCs tend to fund founders that are technical and are going to build their idea, or who have built something and have something to show more and more. And so engineers have this kind of built-in advantage to help their ideas get traction. But something else that can make an engineer more likely to be successful at Facebook is if you are good with words, if you're good at selling your idea, if you're good at bringing other people along with your idea, even if that's just convincing your 2 coworkers that they want to work with you on hack night and prototype out what you're talking about. So once you have an idea, it starts to gather some momentum. We'll tend to put together a team around this idea, whether it's a development of an existing feature or a brand new feature. And a product team at Facebook we run some of the smallest product teams that I think exist in the industry. And so a new feature, like a significant new feature on Facebook, like the new questions product we shipped last year, was actually built by 2 engineers. Something big like the new homepage rollout was maybe 10 or 12 engineers total, and probably essentially 3 or 4 on the UI, what you actually encounter on the homepage. A lot more on the back end. So these are relatively small teams, which means every one of those people has enormous leverage. There's usually a product manager in the mix. There's usually a designer in the mix, because we want our products to be beautiful. And so there's someone that is moving pixels around in PowerPoint, sorry, not in PowerPoint, in Photoshop, and making this look lovely. And so, and then it tends to be that, our cycles are almost unpredictable. I cannot tell you how long it takes to develop a new feature or a new product at Facebook. I wish I could, but in the 15 months I've been there, it seems like each one is different. And what tends to make them different is that our approach is extremely iterative. We don't ship features on a schedule. It's not like VMware. VMware made money selling software. And so if we were going to ship Fusion 2.0 in Q3, we were going to recognize the revenue for it in Q3. And if it wasn't ready to ship, and we would ship it in Q3. And if we had to cut features to make it fit, we would. Facebook's revenue does not come from selling our software. The service is free. It always will be. And what that means is we can take our time and make the feature be right, or we can also sort of go in a hurry and see what the reaction is and fall back very easily. And it tends to be that most of the time that we're building features, we are actually building them in the production code base of Facebook.com. So if you, the web servers that serve up Facebook.com to all of you are actually also running the code for all the features that we're developing right now and that will ship over the next 2 to 6 months. And those are simply, and if you're wondering how could that possibly be, you already know the basic programming structures that enable it to be possible, right? You can imagine a system where the code is running and it has some series of checks. If you're a Facebook employee, if you're in this beta group, run this code. Otherwise, if you're a production user of Facebook, run that code. And so that system, which we call Gatekeeper, enables us to develop our products in the live Facebook.com and really experience it and use it as our users would use it. And it also gives us a lot of power to sort of turn it on for a small number of users and see what the reaction is, and then turn it off again. And so primarily the process of developing a product doesn't start with a very fully realized spec. It starts with an idea. It starts with some engineers building prototypes. It may start with some Photoshop mocks of what it could look like. And then we just start building it. And then we sit with it and we see what it feels like to us. And the principal actor here is at Facebook very much is the engineer, because as much as you can look at a Photoshop mock and say, oh, that would be awesome, I would love to use that, it's only once you get it live and actually powered by your own social graph and your own friend data that you start to feel like, oh, maybe this is not so good. The homepage that we just shipped in particular, we probably went through 5 really major different conceptual takes on what we wanted to do with the homepage. And so we probably sunk 2 months into each of those, anywhere between 2 weeks and 2 months into each of those iterations. The 2-month longs were the most heartbreaking, honestly. But that's maybe another thing that you have to have as a software engineer, is a certain amount of resilience and willingness to say, hey, this didn't work. I'm going to walk away from that sunk cost and try again. And so over this time, we both had a set of people working on the back end for Newsfeed that were making scalability changes, that were creating the ability for us to do much more interesting aggregations of stories. Something that may or may not be that noticeable in the new Newsfeed is that there are many more sort of clusters of stories. We're trying to put more stories together in a more dense way for you. And that was something that required significant back-end changes. And we had a lot of people working on the algorithms to recommend top stories. But the UI, and that work kind of sort of progressed linearly forward, although we made a lot of changes to ranking and to sort of the pacing and the volume of the stories. And it really was just a process of trying lots and lots of experiments, some of which we only ever turned on for Facebook employees, some of which we turned on incrementally for small numbers of users, well, for large numbers of users, but small percentages of users. It's sort of a very common test group size for us is 0.5% of active users. And that doesn't sound like very many, but when it's 0.5% of 800 million, it's actually a lot. But the nice thing is you can turn on that test and have really good data within a couple hours. So it's a very high leverage place to build products, if that's what you like to do. And as we got closer and closer to a product that we really felt good about, then we kind of entered a phase of refinement and polish, and really sort of opening ourselves up to criticism from a lot of employees and a lot of beta users, and taking those to heart, fixing bugs, and really supplying a level of polish that made us feel good about our creation. And then, last but not least, announcing it and launching it to users. So that's kind of the life cycle. And actually, that's not last. It's neither least nor last. Because as soon as you turn something on, you find out things that you didn't really know before you turn it on. And so there's very much a part of the Facebook product launch process, which is continuing to iterate even after you ship and making it better and better even after we ship. And that's a process that continues to this day. So I feel like I've been talking for a long time. And so I would actually love to pause here and maybe just take some questions from you guys. What can I tell you about software engineering, or up there in the pew, in the white T-shirt? What are the major ways in which Facebook generates its revenue? We're an advertising company. We make our money mostly from ads. We also have a system called Facebook Credits, which you can purchase virtual currency for use, mostly for virtual goods only, mostly for use in like Facebook games, essentially. But it's primarily an ad company. And by the way, if you think of the most successful consumer-driven properties, online, they've all been ad-supported businesses. Any other questions? Over here? No, just stretching. Yes? What is the male-to-female ratio at Facebook? Not a public number, but I will say it's not good enough, and it's something that we're trying to make better. I think that anecdotally, Silicon Valley is not, part of the reason we don't share these numbers is we actually don't want it to be a self-fulfilling prophecy. And so I think a lot of Silicon Valley companies are cagey about sharing those numbers precisely because we don't want to discourage women. But anecdotally, what I will say is I think Facebook is doing much better than most other Silicon Valley companies in terms of having women in actual coding positions and management positions like mine, rather than kind of auxiliary functions like QA and tech support. I think the other thing Facebook's doing really well at actually is acceptance rate for whatever reason. One of the things that I did when I started, so I am passionate. If you Google me, you will find me talking about getting more women into computer science and getting more women at Facebook. It is one of my passions. I think the world is actually missing out on half of it, literally half of its software engineers. And so one of the things that I did when I got to Facebook was to really go through our whole hiring pipeline with a fine-tooth comb, looking for discrepancies between men and women. And actually, the only major discrepancy I found is that women accept our offers at a higher rate. There's about a 10 percentage point spread. Yeah. If you're a minor employee, you mean under 18? The question is, if I'm a minor employee, how important are my ideas? Minor meaning just an individual contributor, I think you're trying to say. I think I want to say to you something that is going to sound cheesy, but I think is demonstrably true, which is that there aren't minor employees at Facebook, and that everybody's ideas have impact. And I think the best way to, at least in engineering, I can't speak for every function in the company because I haven't experienced them all firsthand. But what I would say about engineering is that if you look at the leverage of being an engineer at Facebook, it's almost unique in the history of the software industry. So if you think about the spectrum of the impact you're going to have on the world, and we think a lot about this because I think one of the core values at Facebook is making a big impact and doing things that are very high leverage. A lot of people, when they think about having a big impact, they think about going to a very small company, right? Where they are going to be one of a very few people in the room, and where they're going to be involved with every aspect of the business and make a ton of decisions. Man, when I did my startup, there were 4 of us. Like, I was involved in every single decision, whether it was, what was our product strategy, down to like, what sodas are we going to buy in the kitchen this month? And so if you're somewhere very small, you're going to have a very big impact on your business, but the nature of working at a 5-person or a 20-person startup is that your startup is the standard startup experience. Very few are extremely successful and break out of this, but the standard startup experience, especially at first, is that what you're doing affects very few people in the world. You just don't have that many users yet. And so your impact on your company is large, but your impact on users, on people, is small. Then you can kind of go to the opposite end of the spectrum, and I think this is more the experience you're talking about, where you have these sort of very large, well-established companies that are having a ton of impact on people in the world. Think of Microsoft, think of Google, and or for that matter, think of IBM and Cisco and Intel, really giants of the high-tech industry. And they have hundreds of millions of users. They've saturated them. They've got every user you could imagine. And yet, at the same time, they have tens of thousands of employees. And so the impact that each individual employee, that each individual engineer can have on those people in the world is also pretty small, right? I mean, sort of getting back to the thrust of your question, like, oh, I'm just a little cog in a wheel somewhere. I can't be like, Apple may be changing the mobile phone industry, but like one engineer on the iPhone probably cannot. But I think that if you picture a graph which has number of engineers on the x-axis and users per engineer in the y-axis, I think the graph actually looks a bit like a hill. And I think Facebook is sort of close to unique in being, very close to the top of that hill. I think we're approaching the top of that hill, where we have 800 million users. We have fewer than 800 engineers. And so the ratio of users to engineers is literally more than 1 million to 1. And so we have so much more work than any individual could do. And so every single person at Facebook has to think about, what is the most impact I can have on our users? What is the highest leverage that I can be and do? When you think about building a new feature like questions with just 2 engineers, when you think about, and by the way, those 2 engineers weren't like, senior staff principal engineers. One of them was 3 years out of college, and one of them was no years out of college because he was a summer intern who had dropped out and stayed. And so, and those 2 guys built the whole thing, and trust me, they had more impact and more say over that feature than anyone else involved. So, are you necessarily going to be able to, walk into Sheryl Sandberg's office and say, I think the sales plan should be something different? No, like your impact is going to be felt in the area of your expertise of what you're working on, but in that area, it's huge.
How do you cope with the fact that for at least 2 weeks after a new Facebook comes out, most people hate it?
How do we cope with the fact that for at least 2 weeks after a new Facebook comes out, most people hate it? It takes some coping. I'm not going to lie, not one of my favorite parts about Facebook. Actually, it seems like it's mostly homepage that draws that response. In fact, like we've done this sentiment analysis, and we do sort of this graph of like positive versus sentiment, like where we scrape people's public status updates that include the word Facebook. And positive spikes are like positivity sentiment spikes are usually things like holidays where people are saying Happy Mother's Day to all my Facebook friends who are moms. So those are not about us. But the negative ones are bring back the old Facebook. And almost all of the negative spikes are correlated with homepage rollouts. It's, you know, if anything, the fact that it does happen very predictably makes it easier. Like going into rolling out a new homepage, we kind of were a little bit, you know, braced for impact. But you know, it also, every time people complain, there's almost always, like, sometimes, yeah, it's just I don't like change, but there's generally a lot more at the root of it, right? I mean, I think the complaints about the homepage this time, you know, had a lot of legitimacy to them. I mean, you know, I think it's true that if people are really happy with your service, and that's the most heartening thing, frankly, that people wouldn't be complaining this much if they didn't care so much, right? If they weren't passionate about Facebook, if they weren't passionate users of my software. And like, at its heart, that's so much better than working on something that just doesn't matter. But also, like, people are going to complain about change, but the thing they complain about is going to be the thing that you need to fix, right? Or is going to be the thing that you strategically chose to do and you're going to stick to your guns about. And so there are, well, no, I'm serious. I mean, maybe the most illustrating story, actually, this is a good story if you haven't heard it. When Facebook first rolled out Newsfeed in 2006, so this is hearsay, I was not at Facebook at the time. But at the time, Facebook had about 50 million users. And when they rolled out the Newsfeed, the outrage at the existence of Newsfeed, because before, like, you had to go stalk, you had to visit someone's profile to see what they were up to, right? You had to stalk them. And as you may recall, if you were any of you using Facebook in 2006, and the newsfeed, all of a sudden, all this behavior, all this activity people were doing on Facebook was visible to their friends before, but they kind of felt like they had security through obscurity. Only people who cared would go and look. And now that was all being pushed out to the world, or out to their friends. And so the outrage, literally 12 million people, 12 million Facebook users joined a protest group protesting the existence of the newsfeed. 12 million out of 50 million users, like an insane percentage. At the same time, our servers were going nuts. And we had data showing that the self-same people, like, that of our 50 million users, almost all of them were using the site much more frequently. We're spending more time on the site. We're consuming these stories. We're visiting each other's profiles more often. We're friending more people because they were discovering more. So we could tell, even through the complaints, like, that gave us the courage to stick to the strategy change, to stick to our guns, because we could see that users loved it and that it was giving them value. And everything we do is for the purpose of creating value for users. Yes, secondarily, like, we want to be able to monetize that so that we can continue our mission. But if we just wanted to generate advertising dollars, there's a lot of things that we could do. We could make ads bigger, whatever. The worst thing we could do for our revenue would actually be to do something that made people visit the site less, or friend fewer people, or switch. So users and user engagement are always at the heart of our strategic decisions, and revenue is something that's kind of an afterthought. It's literally a separate organizational function because it will follow if we make users delighted. So in the case of these changes that we make, something that gives us the courage to stick to our strategic guns is if we see that users really love the features, that they're really using them, that it's really making a difference and helping people. And it also helps to actually just pay attention to what people say and realize that, oh, we actually could fix that. It's in our power to solve a problem that the new interface has created for you. And so we do that too. And I suspect I'm running out of time based on
but I think
bustle.
you can stick around for bits to answer questions one-on-one. So, well, thank you
I'm
so much, Jocelyn, for joining us today.
My pleasure.
Thanks so much. So this is CS50. We'll see you Wednesday, and Jocelyn will be up here up front for a while. Thank you.